Intermolecular forces. Polar molecules. Electronegativity occurs because the electrons in a covalent bond will not be shared equally between the atoms. A greater electronegativity means there will be a greater pull on the electrons. The electrons will be slightly displaced due to this and will create a small polarity across the bond. Hydrogen fluoride will have a positive charge on the hydrogen and a small negative charge on the fluorine because the fluorine is more electronegative. Electron density is used to describe how the negative charge is distributed across a molecule. Dipole moments. A dipole moment is a measure of the polarity within a molecule, and it occurs where there is a separation of charge between two or more atoms. This can occur in ionic and covalent bonding. The bigger the electronegativity, the greater the dipole moment. The distance between the charge separation also determines the size of the dipole moment. When two charges are created that are opposite but equal in magnitude, a dipole will be created. The size of a dipole moment is measured in this little symbol. And if a molecule has a dipole moment which needs to be greater than a value of 0, it is a polar molecule. London dispersion forces. They are sometimes known as induced dipoles. Even if a substance is neutral, it consists of positive and negative charges. These charges produce a weak attraction in the molecule. They occur with all the molecules and atoms in addition to other forces. At any given moment, the electrons can be located anywhere within the orbit of an atom as they are in constant motion. The movement of the electron cloud causes these London dispersion forces. There will be temporary dipoles formed where the electron clouds occupy temporary positions that cause unequal sharing of the electrons. This is because there will be a more negative charge where the electron is located and a more positive charge away from the electrons. The electron clouds interact with neighbouring atoms to form temporary dipoles in them as well. The temporary dipoles will then cease in the next moment due to their constant motion. Their strength depends on how easily the electrons can move and be polarised. The bigger the atom, the more electrons are there, the bigger the charge, and the more likely it is to be polarised. In larger atoms, the forces will be greater, which causes higher boiling points. Dipole-dipole. These only exist between certain molecules and are stronger than van der Waals. They exist between molecules with permanent dipoles only. For example, in hydrogen chloride there is a permanent dipole because the chlorine is more electronegative than the hydrogen. As a result, chlorine will have a slight negative charge as it pulls the electrons closer, and the hydrogen will have a slight positive charge. Hydrogen bonds. These form when hydrogen is between two strongly electronegative atoms, like oxygen in water. They are the strongest intermolecular force. This strongly electronegative atom must be at least one lone pair of electrons. These bonds form between the lone pair of electrons and then the heavily deficient hydrogen atoms, as you can see here. And in water, it forms a network. Hydrogen bonds are incredibly important for the reason that water allows all living things to exist. The hydrogen bonds will cause cohesion and adhesion, a high specific heat capacity, high latent heat of evaporation, and low density of water. In regards to cohesion and adhesion, this is the ability of water to attract other water molecules due to their dipoles and therefore form bonds. The hydrogen bond holds molecules together and allows surface tension, which is essentially why insects can mobilise on water. It also allows capillary action, which is characterised as water appearing to climb, for example, in a tube. High specific heat capacity. This is the energy required to increase the temperature of 1 kilogram of water by 1 Kelvin. A water has a high specific heat capacity because more energy is required to heat it. And only breaking these hydrogen bonds can those molecules move freely. A high latent heat of evaporation. This allows water to moderate and regulate its temperature. It prevents any rapid increase or decrease in temperature and state changes. It is the amount of energy needed to turn liquid into gas, and it is the reason for why lakes and reservoirs don't dry up that easily. In addition, evaporation allows cooling in many creatures, including humans, when we sweat. Low density of water. In low temperatures, hydrogen bonds are more stable and they are more spaced out. As a result, ice will not only maintain its shape but float, as there are less water molecules required in ice than there is in normal water. Ice's ability to float is essential for life, from in the polar caps to heating the water beneath and allowing animals to survive, to just like allowing creatures to live on top as well, penguins, polar bears. The end.